In this situation, we are given that there is a ball of weight W. So that might suggest then that we have a weight, Fg or W, which means there's going to be a normal force like this, Fn. Those will be equal and opposite. Because the ball does not accelerate up and down, forces must be balanced. At T, it's moved from point P to E of the surface. It falls freely to point Q. So this is time T that happens here, which one shows the variation time of the resultant upward vertical force acting on the ball between P and Q. So if we go to P, we have those two forces. The normal force is acting upward. When we get to T, the moment after T, there is no upward force. The only force acting on it is gravity the entire rest of the time. So we might suspect there is an upward force in the beginning. Which we might say is equal to positive weight. Fn equals Fg, it's equal to positive weight. And then at time T, it goes to 0. So if we look at choice A, this says the upward force is 0, and then the upward force becomes negative, which is kind of resultant upward vertical force between P and Q. So we can understand this here, but it's talking about the upward vertical force. And so the upward force doesn't become negative. The upward force becomes 0. So here we start with it being positive W, and then at T going to 0. So it looks like this is the answer. We'll consider the others. We have 0 upward force, and then an upward force instantiates. That's not true. And then in D, we have a negative force that becomes 0. That, again, is not true. We're not starting out with a negative positive force. So that's why we have choice B.